Hi everybody, now let us start another subject we will discuss together in your syllabus about physics, which is scalar and vector quantities. But before starting this part from your syllabus of physics, I want to remind you two very important points about physics. If you want to be talented in physics, don't say that you will do your best. Why? Because, sorry, I have to tell you that your best isn't enough. To be talented in physics, you need to do what should be done. You need to do what should be done. Physics need practice. Physics need attention. Don't put a certain time in your week for physics, but daily you need to practice physics. Physics isn't like any other subject. You learn it by heart and repeat it again and again and again. Physics isn't like that. Physics is process. Physics is a way in thinking. So please don't deal with physics as you're dealing with the other subject. Study physics every day and you will find everything okay. Number 1 and 2 and 3, to be good in physics is practice. Studying daily. Practice every day, like language. If you don't do physics every day, your ability in physics will be weaker each day. If you do physics every day, like the exercises, your mental muscles will be bigger and greater. Okay? Now let us start our discussion together about scalar quantities and vector quantities. What's the difference between scalar quantities and vector quantities? And why we need to classify the quantities to these two types? Today, if I told you, for example, I walked 100 meters. And after that, I told you I walked 100 meters from home to school. What is the difference between the first example and the second? I walked 100 meters. I walked 100 meters from home to school. What's the difference? Of course, after thinking, you can tell me that the first example tell us about the number only, 100 meters only. This number is called magnitude. Magnitude. There is no details about the dimension, the direction of the motion. The second example, 100 meters from home to school. So here the number, which is called the magnitude, and the direction from home to school. These details is very specific and very important. So the first example give us the magnitude only, which is called scalar quantity. Scalar quantity means this quantity to be described. It's enough to give me the magnitude only. Like what? Try to think with me. Try to think about an example for something need to be described only magnitude. By another words, if I told you the number only, this will be satisfied. You will be satisfied. You will have a full picture about this quantity. Can you tell me an example? Try to think. Something need only number. There is no need for telling you about the direction. Try to think. What? Think. What about something you studied before? Gravitational acceleration. The acceleration of the Earth, or the attraction force of the Earth on the bodies. What do you think? Is this example scalar quantity or vector quantity? What if you throw any object from your window? The Earth will attract this object upward or downward. Of course, will attract it with a number, specific number, downward, which is called the weight. And it's important to tell me the direction, because there is no objects fall upward, of course. All the objects fall downward. So here there are 2 points: the magnitude of the force, or the magnitude of the acceleration, and the direction toward the Earth. So this example isn't scalar, of course, because there is here something about the direction. But this is called vector quantity. It isn't scalar quantity. But I still need from you an example for something doesn't need direction. It's like time. If you are talking about time, you will tell me it's from 10 to 12 o'clock, or it's only 2 hours. So here we are talking about magnitude only. It's only number. There is no talking here. There is no signs. There is no need for telling me the direction, because there is no direction for the time. This is the difference between scalar quantities and vector quantities. Okay, if we said that the temperature of a body is 37 Celsius degree, is it a full piece of information? Is it a full piece? What is the meaning of a full piece of information? This means you will be satisfied, you will get a full, clear image about this physical quantity when I told you that the temperature of the body is 37 Celsius degree, or you need something else to illustrate to you, to get you understand the temperature. If we are reported that a car moves at 50 km per hour, is this a clear image? to tell you about the motion, or you need something else to let you understand about this information? I think in the first example, which is talking to us about the temperature, it's enough. When you tell me that your temperature is 37 Celsius degree, I understand that you are okay and your body is healthy due to your temperature is normal. So there is no need for talking to me about the direction. But when you are talking to me about the car moves 50 kilometers per hour, here I don't know the starting point and the ending point of this car. So here we don't talk about the velocity, because the velocity need the number of motion speed and the direction. So if you told me this information, the car moves at 50 kilometers per hour, this means the speed equal 50 kilometers per hour, only the magnitude. So velocity is considered vector quantity, speed is considered scalar quantity. This means velocity contains inside it the speed, because the speed, the magnitude only. If you add to the speed the the direction, so speed plus direction equal velocity. From here, the magnitude and the measuring unit have been given, 50 kilometers per hour. But we still wonder about the direction of the car motion. Is it to east or west, or moving to north or south, or from a specific point to another point, from school to home, from gym to school, or what? When expression that the car moves at 50 kilometers per hour to east, this gives a full idea about the motion. This full idea, we will call it the velocity of the car. That includes magnitude and direction. So, because of all of that, temperature is defined fully by its magnitude only. So that temperature is called a scalar quantity. And velocity is defined fully by its magnitude and direction, so that velocity is a vector quantity. Now, let us try to compare between scalar quantity and vector quantity. Scalar quantity, try to think by yourself about a definition for scalar quantity. Look, dear student, of course you are studying under the umbrella of our system, our smart system. Of course, you are telling yourself that the definitions isn't important, because there is no questions will be in your exam about the definition. This is wrong. Try to train yourself by trying to find the definition by yourself. This will be a very good exercise for you to understand the new philosophy which we will try to train you in it. Now let us try together. Let me ask you, what's the scalar quantity? Of course you can tell me It's a physical quantity that can be fully defined by its magnitude only, and it has no direction. This is scalar quantity. Try to give me an example for the scalar quantity. Try to think with me. We said temperature, number 2, time, number 3. What about mass? Mass and weight. Which is scalar and which is vector? Weight, it is a force toward the ground. So here there is detail about the direction. So weight is vector, but mass scalar. What about the difference between displacement and distance? Yes, of course, distance is scalar quantity, only 50 meter, but 50 meter from point A to point B. So this is displacement, it's vector. Distance is scalar quantity. Yes, correct. Number 2, vector quantity. Now you can tell me the definition of vector quantity. It's a physical quantity that can be fully defined by both magnitude and direction. Here, both magnitude and direction, like displacement, as we said before, velocity, acceleration, and force. Acceleration and force. Now we need to try to differentiate between, practically of course, between distance and displacement. But before that, we need to note that the summation of two scalar quantities, like for example any two scalar quantities like distance and mass, can you add or can you make a summation of these two? Can you make the summation of these two, mass and distance? If I told you that please try to add the 3 meter to 4 kilogram, can you add 3 meter to 4 kilogram? Try to make this addition process. I think you can't. You can't add 3 meter to 4 kilogram. So if you want to add two quantities to each other, it's very important to be sure that the two physical quantities of the same kind. 3 meter can be added to 4 meter only. So 3 meter plus 4 meter, this will be 7 meter. You can't add 3 meter to 4 kilogram. So the first point, if you want to add two physical quantities to each other, these quantities should be of the same kind. Both should be distance. Another point, we can't add 3 meter to 4 centimeter. We can't do that. But the two physical quantities should be measured by the same measuring unit. So here we have two conditions to add two physical quantities to each other. You have to convert meter to centimeter or centimeter to meter, and of course this is called conversion factors. I can remind you quickly by these factors. Of course, you know that gigameter equal 10 to power what? to power 9, yes, gigameter equal 10 to power 9 meter. And terameter equal 10 to power 12 meter. And after that, the smaller than tera and giga, there is megameter equal 10 to power 6 meter. And kilometer equal 10 to power 3 meter. And the meter itself equal 10 to power 2 centi. And meter equal 10 to power 3 millimeter. Meter equal 10 to power 6 micrometer. And meter equal 10 to power 9 nanometer. You can convert by using the conversion factors any measuring unit to another measuring unit. It's very important. So here you have to be sure that the two physical quantities of the same kind. Number 2, the measuring units the same. Number 3, the dimensions the same. So 3 meter equal 4 meter plus 4 meter equal 7 meters. Or 300 centimeter plus 400 centimeter equal 700 centimeter. This is point number 1. Point number 2, the summation of two vectors quantities. If you want to add two vector quantities, velocity to velocity, this will give us the same quantity. Velocity plus velocity give us velocity, of course. Acceleration plus acceleration will give us acceleration. But what about divide or multiplication of two vector quantities? If you add two vector quantities like displacement over time, for example, this will give you another physical quantity, new physical quantity, which is velocity. Okay, so the summation of two vector quantities may be variable because it depends on the direction of each quantity. If I told you that I walked 3 meters to east and another 3 meters to east too, then the total displacement here will be 6 because both of these have the same direction. But if I told you that I walked 3 meters to east, then 3 meters to west, here the direction and the opposite. Opposite in physics means negative. So the total displacement here, 3 minus 3 equals 0. So here if you need to add two vectors to each other, you need to be careful for the direction. It's very important. Okay. Now the vector quantity, if we need to differ between the distance and the displacement, first let us talk about the distance. Here distance, it's the length of the path moved by an object from a position to another. If here a car moved, for example, from A to B, then moved from B to C, then from C to D, and after that moved from D to E. Here, if you want to calculate the distance equal AB plus BC plus CD plus DE. It's a magnitude. It's only a magnitude. Its magnitude is always more than the displacement. Why? Because if you want here in this example to calculate the displacement, its definition is the shortest straight line. It's the shortest straight line from a starting point to ending point. Or by another words, it's the length of the straight line segment in a given direction between the starting point and the ending point. Here in our example, we said that the object move from A to B, then to C, then to D, then the ending point is E. So the displacement here is the shortest straight line from A to E. So displacement here equal AE. Its magnitude is always less than the actual distance moved by the object. So from here, if you are trying to calculate the distance or displacement, you will find that the value of distance always more than the displacement. Why? Because the distance affected by direction, but the displacement distance don't affect by direction, because the distance is a scalar and displacement affect by direction due to its a vector quantity. Now let us talk about some very important notes here. If an object moves in one direction, imagine that an object moves in one direction. This means maybe this direction is from A point to B point. Here the distance will be AB and the displacement will be AB2. This means that the distance equal the displacement. The distance equal the displacement. Okay? Note number 2. If an object moves in one direction, then return back to its starting point. This means that this object moved from A to B, then returned back from B to A. Here the distance, of course, will be 2AB, and the displacement equal 0. Why 0? Because the displacement equal AB, but minus AB, it's the returning back, so the total displacement will be 0. Third point, if an object move in a covered path, its curve from A to B, here the distance will be the actual path, the actual curved path from A to B, but the displacement is the shortest straight line from A to B. This means the displacement will be smaller than the distance, of course. Point number 4, if an object moves in one direction from A to B and then return back to point C. C is a point between A and B. What about distance and displacement? Of course, the distance will be AB plus BC, because distance doesn't affect by the change of the direction. But displacement will be AB minus BC. Why minus? Because displacement is vector quantity and it's affected by the change in the direction. Okay, now let us complete our discussion here. Before telling you an example for the problems and ask you to calculate the distance and displacement, let me remind you that the vector quantity is written as it's a quantity. So if you need to write it, we can write it by an arrow. This arrow has a length and has a starting point and has a direction. So this arrow, its length points to or indicate the quantity of this vector. It is a quantity, it is a magnitude. But it points to a certain direction. It is the direction of the vector quantity. And its starting point, it's the point which from it the physical quantity start to move. The second point, the product of a scalar quantity and vector quantity equal what? Scalar times vector. Mass times acceleration. Mass scalar, acceleration vector. It will give us mass times acceleration equal weight. So here weight is vector. From here I can tell you that scalar quantity times vector quantity equal vector quantity. Like another example, time times velocity. Time times velocity here, as you see, equal displacement. It's a vector quantity. What about the product of two vector quantities? The product of two vector quantities, like what? Like force times displacement. Force is vector, displacement another vector. This equal work. Work is scalar quantity. Work scalar quantity. So vector times vector equal scalar. The product of two scalar quantities. Two scalar quantities like length times width. Length times width equal area, and the area is a scalar quantity. So finally, vector times scalar, it's vector. Vector times vector, it's a scalar. Scalar times a scalar, it's a scalar quantity. Now we can make quickly the difference between distance and the displacement. As you see here, distance is defined as the length of path moved by an object from a position to another, and the distance is a scalar quantity that can be fully defined by its magnitude only. But displacement, when the distance is associated with direction, then it's called displacement. Displacement is a change in the position of an object, and it's given by the length of the straight line in a given direction between the starting point and the ending point. Okay, now let me ask you this question. Try to answer this problem with me quickly. If I told you an athlete has moved to west through a displacement of 50 meters, then moved back to east through a displacement of 30 meters. Don't forget, moved to east 50 and to west 50 and to east 30. Calculate the distance and the displacement of the athlete. Of course, distance will be, its symbol is S. Distance, its symbol is S, so S equal 50 plus 30, it's equal 80 meters. And the displacement, its symbol is D, it's 50 minus 30. Why minus? Due to the athlete moved in the opposite direction. This is the answer will be 50 minus 30 equal 20 meters, and the direction should be to the west. Okay, moved to the west. Here, let me ask you another problem, just to understand what's the difference between distance and displacement. If I told you an object moves along the circumference of a circle of radius 2 centimeters, Find the displacement of the object when it moves. I need from you to calculate the displacement. It moved half revolution and moved a complete revolution. If the object moved half revolution means it moved half the circle from A to B. Half the circle. This means half the circumference. So of course you know that the circumference of the circle is 2 pi r. If you want to calculate the distance here, the distance half the circumference. So it's half times 2 by r. So the distance will be by r, due to we can cancel 2 with the half. By 3.14 times 2, which is the radius. This is the S, the distance. What about the displacement? If you connect between A point and B point, you will find that AB is considered the diameter of the circle, which is 2r. So the displacement here equal 2r due to r plus r. So 2r, which is r plus r plus r equal 4 centimeter, and this is the displacement. What about the second one, which is complete revolution? If the object moved a complete revolution, so the distance here will be a complete 2 by r. So 2 times 3.14 times 2, this will give us the distance. What about the displacement? We said that the displacement is the shortest straight line from starting point to ending point. This means the starting point is the same ending point. So the displacement here equals 0, because the starting and the ending is the same point. Okay? Now, how we can represent the vector quantity? It's represented by a directed straight segment whose base is the starting point and its tip is at the end point, and its length is proportional to the vector magnitude, and its direction is the direction of the vector quantity. So it's denoted by the A letter, bold A letter, tagged by a small arrow upon it. This is how you can write the vector quantity. If the teacher has asked student to locate, the position of the physics lab relative to the position of his classroom, he may reply that the lab lays at 40 meters to the west of the classroom. This quantity is called the position vector of the physics lab. In this example, the vector is represented by a directed straight line. As the magnitude increases, of course, the length of this arrow will increase. And always this arrow points to the dimension. It points to our dimension. Okay, so the vector is represented by an arrow drawn at a suitable scale, where the arrow lengths represent the vector magnitude and the arrow direction represent the vector direction. So now let us talk about how the vectors be equal or the vectors be unequal. We will complete this point during our discussion now, but before this I want to give you some questions to make it as an exercise for you. Now let us start this exercise.